Hello, dear students, and we are back again to complete and explaining chapter 4. And we reach chapter 4 in physics grade 10, and in which we reach in this topic latent heat. And yesterday, or not yesterday, I think the previous video that we have explained their types. We have two types of latent heat of fusion and latent heat of vaporization. And even though we have explained both of them, latent heat of fusion that is the energy per unit mass, but in latent heat fusion, the state of the matter, it must be changed from the solid to liquid, or solid to liquid, or liquid to solid. And here that you have, we started on latent heat vaporization, liquid to vapor, and vapor to liquid. And even though we have explained the graph too, we have some regions that in which of the region that the temperature going to be increased, or and so on. We did all, we have done. So in here now we reach page 93. So in here now we have solving example about latent heat. So now be with me, inshallah. We are trying to finish chapter 4 today all. Today lesson we have solving exercise about latent heat. So be with me please to solve the first sample problem for C. Question 1, how much energy is removed when 10 gram of water is cooled from steam at 133 to liquid 53 Celsius. First of all, we have to know that in this temperature that we have 133 is above 100. Because this is above 100, we know this at 100 Celsius the waters become boiling. At 100 Celsius, this is boiling point. But in here that you have above 133, so above 133 it means steam. In the graph we have studied, if you remember. But below, this is water below. Water state, liquid. But at 100 Celsius become boiling, and but above 100 Celsius becomes steam. So in here we have 133 Celsius. So at 133 Celsius, in here it means the state of the matter in here that you have, it's steam. So the question said we need to cool. Of water is cooled. We have to cool. We need to cool this state of matter. We have water is cooled from what? Steam to liquid. So in here we have steam. We need to decrease this temperature until become 53 Celsius. So of course in here certain liquid at 53 Celsius. Of course less than 100 the state is liquid, and because less than 100, so this is liquid. So now in here we need to convert the temperature of the steam from 133 Celsius to 53 Celsius, and 53 Celsius become liquid. And in general, now we want to convert this phase of we want to convert the phase of the matter. It is called phase change from steam to liquid. We have to cool this temperature. We want to decrease their temperature from steam to liquid. In here, immediately, directly, we cannot make it 133 from steam to liquid. In here, we cannot directly. We need some steps to convert from 133 Celsius to 53 Celsius. First of all, the first state in here now, we have 133 Celsius. This state is steam, we know that. And suddenly, directly to convert to liquid, we cannot. It must be passed. We have to this state of the matter, they have to pass through some steps, then at the end we can make it liquid. The first step in here, from 133 Celsius, this is steam. Let me show you by the graph, the table, or this graph that we have studied. And here, look, with this graph we have how we can make it steam to water. How we can make it. In here the temperature, we have to what? You have to decrease the temperature from the high to down. You have to decrease the temperature. How? First of all, to convert steam to water, First of all, look, to convert from 133 Celsius and to water, first of all, we have to convert it from 133 Celsius to 100 Celsius, then from 100 Celsius to 53 Celsius liquid. How we can decrease their temperature from 133 Celsius till 53 Celsius? First of all, we have to say 133, then 100, then 53. Immediately, directly, we cannot make it this number to 53 Celsius, because in the middle we have 100 Celsius, and I told you this is boiling point. Step by step. First, from 133 Celsius, the steam to 100 Celsius, then below 100 Celsius, I told you, below 100 Celsius is water, above steam. So between of them, we have 100 Celsius. So first of all, from 133 Celsius, make it boiling point, then to liquid. So first in here, the previous video that I told you, if you have two temperature, we have to use mCp delta T. So in here we have to find energy. The first energy in here, I'm going to write down the first energy equal to mCp delta T. So instead of the mass, the question they told us the mass it was 10 kilogram. Sorry, 10 gram. The mass it was 10 gram. But you know that in most of the physics lesson we have to make it gram to kilogram and multiply by 10 power negative 3. This is become kilogram. Yeah, the mass it will be 10 times 10 power negative 3 what? Kilogram. To convert gram to kilogram, multiply by 10 power negative 3. So you have the mass now. Instead of the mass, write down 10 times 10 power negative 3 and times what is the Cp of steam? If you remember, we said each of the set of the matter they have their own Cp. What is the Cp? All of them we will give you in exam. So no worries. So the Cp of the steam, which equal to 2.01 times 10 power 3. This is Cp of the steam. Then multiply, and instead of delta T is left in here. Every time you have to minus bigger number by small number. Tf minus Ti. So 10 times 10 power negative 3 times 2.01 times 10 power 3 times in here look Baba. Tf, and instead of Tf we have to write down 133 Celsius minus and 100 Celsius. So let me use calculator. First of all, multiply all of them. If you are clever in math, this 10 power negative 3 with this 10 power 3, because they are same number, but this negative is positive, both of them are going to be cancelled out. 10 is left. 10 times 10 times 2.01. This will be 20.1, and write down 20.1 times, and inside the bracket 133 minus 133 it's left. So multiply both of them and times 33. The answer of the first energy will be 663.3 joule. We know that unit of joule is unit of energy is joule. So this is the first energy we have done. First, to convert 133 Celsius to 100 Celsius. The second energy in here, how we can find second energy? Don't do mistake. Most of the students say, Mr. we have to use this temperature again. Use Cp delta T. No, we have to alone use the 100 Celsius in individually. Use this 100 Celsius in the rule. Why? Because if you remember the previous section, I told you 100 Celsius. This is vaporization. In vaporization, they have their own rule, which is equal to MLV, using this rule MLV. Why, Mister? Because 100 Celsius is the boiling point, vaporization, converting from liquid, for example, to vaporize. When you are increasing energy, it becomes boiling point. 100 Celsius in 100 Celsius, the rule every time mLV. But if we have 0 Celsius, we have to write down mLF. So if you have 100 Celsius, use this rule every time, and individually, not to immediately to take this to temperature. No, first of all, find the second energy find the second energy of this boiling point. Yeah, you have to use the same mass, 10 times 10 power negative 3, and LV, latent vaporization. Latent heat of vaporization. But in here we have latent heat of vaporization. The number we have 2.26. 2.26 times 10 power 6. As I told you, we'll give you this all exam. You can calculate both. The second energy will be 2.26 times 10 power 4 joule. Finish. Only the last energy is left, energy number 3. Now we can take both of them between 100 Celsius and 50 Celsius, 100 Celsius, 53 Celsius, because both of them we have two temperature, so we can use CPM delta T. Yani first step, we have to take both of the temperature, 133 with 100 Celsius, use CPM delta T. The second energy, individually alone, use the rule of 100 Celsius, which is equal to mLV. The last energy, use this two temperature, write down 100 Celsius with 53 Celsius. Yalla. mCp delta T, and instead of the mass, again write down 10 times 10 power negative 3 times Cp. Now we have to write down Cp of which one of them, steam or liquid. Be careful. Now we are in this phase, this state. In here we should, or we must write down the Cp of the water, because in that state the temperature is 53 Celsius, and 53, the state in here is water. It's not impossible in that state to write down the Cp of the steam, because we are working in this range, and this range, the state of the matter is liquid. That's why we have this mass Cp 4186. This is the Cp of water, times delta T again, Tf minus Ti, and again the greater number minus small number, 100 minus 53. 100 minus 53. So again, calculate both of them. The answer, energy number 3, will be 1.97 times 10 power 3 joule. So in here now we have found the 3 energy. The last step, you can find the total energy, 2 plus all of them, Q1 plus Q2 plus Q3, plus all of them. Q1 it was 663.3 plus, and Q2 2.26 times 10 power 4 plus Q3 1.97 times 10 power 3 joule. You can plus all of them. Total of the energy will be the answer 2.52 times 10 power 4 joule. This is the answer of first question. The second example. Exercise. In exercise, the first example. Now, look. Actually, question 1, it needs a lot of step, but still I'm going to stop for it, okay? But really it takes so many time. Question 1, how much energy is required to change from which state of matter, from which phase, from ice at negative 99 freezing, is solid state, from ice to what? 111 Celsius. Yani in here we have to convert from solid to what? To steam. From which temperature? From negative 11 Celsius to 111 Celsius. So in here it takes a lot of step actually, but still I'm going to do it for you. It's okay. Look, first step, the temperature of the ice, which is negative 11 Celsius. The question said convert this state of matter, this phase, which is ice and solid, make it convert to what? Change to what? To steam. To steam. At which temperature? At 111 Celsius. يعني you have to make it negative 11 from freezing ice solid state to 111 at steam phase at phase state of matter. So first of all, we have to make it 111 Celsius. And in that case, you have to increase the temperature. We have to increase from 111 Celsius. You have to start from 111. We have to start from negative 11 Celsius until 111 Celsius. يعني first of all, يلا. Negative 11 Celsius. We have a rule, if you remember, we have a rule of 0 Celsius. First, you have to start from 111 Celsius till 0 Celsius. Then, from 0 Celsius, from 0 Celsius, because in here, we have to convert, you have to convert step by step from 111 Celsius till 111 Celsius till 111, from negative 11 Celsius, sorry, till 111 Celsius by doing some steps. First, from negative 11 Celsius till 0 Celsius, then we can converting so we have to change or convert from negative 11 Celsius to 111 steam by doing some steps. Suddenly, immediately, directly, it's difficult and so hard to directly convert from ice to steam. This ice, they have to pass through some step, through some process, then we can make it steam. Immediately, directly, we cannot make it solid to steam. They have to pass through some process, some steps, then at the end we can, it can't be steam. So first of all, from negative 11 Celsius till 0 Celsius, then after 0 Celsius we have 100 Celsius, then after 100 Celsius we can make it steam. Each of the phase now, before we have studied, first negative 11 Celsius to 0 Celsius. The 0 Celsius we have studied, and I told you in 0 Celsius we have to use MLF, but in 100 Celsius we should use MLV, and to take to temperature we should use MCP CP delta T. So first of all, the first energy in here, we have to take this to temperature, MCP delta T. What was the mass? The mass in here that we have 42 gram, but 42 gram, as I told you, convert to kilogram will be 42 times 10 power negative 3 kilogram times in this range, negative 11 Celsius till 0 Celsius. In this range, we should write down the CP of the ice. CP of the ice 2.09 times 10 power 3. And times, instead of delta T, as I told you, minus the bigger number with smaller number. So the bigger number in here is 0 minus, and this number still is minus 11. So 42 times 10 power negative 3 times 2.09 times 10 power 3. This will be 0 plus 11. You can, the same thing, these two numbers are going to be cancelled because they have same number and different sign. So 42 times 2.09 will be 87.78, and times 11, the answer of the first energy in here that you have 965.58 joule. So the first energy, now we found the first energy. This energy, You know what is the meaning of this? It means that we need this energy, this value, we need this magnitude of energy to convert from negative 11 Celsius to 0 Celsius. يعني we need this value. We have to give this ice, we have to give this negative 11 Celsius, this ice state, this number, this energy, then we can make it 0 Celsius. يعني we have to give this energy to the negative 11 Celsius, then we can make it to 0 Celsius. Okay, we have done this to temperature. Then at 0 Celsius, find the energy of this step individually, because in here 0 Celsius, this is MLF. The second energy in here we have MLF equal the mass, the same thing, the mass 42 times 10 power negative 3 times latent heat fusion. LF we have 3.33 times 10 power 5. So times all of them, and the answer 1.4 times 10 power 4. 1.4 times 10 power 4 joule. This is the second energy of this temperature, 0 Celsius. After that, again, we have to take these two temperature. We have to take this to temperature 0 Celsius with 100 Celsius. Because this is two temperature, we have to use which rule? CPM delta T. Every time, if you have two temperature, use CPM delta T. But if you have 0 Celsius, use MLF. But if you have 100 Celsius, use MLV. So in that case now, first of all, we have to use CPM delta T. After that, when we'll finish, then we can use MLV for finding energy of 100 Celsius. So, yalla. The third energy, MCP delta T, yalla. The mass, this is still same mass, 42 times 10 power negative 3 times CP. Be careful, most of the students, they don't understand, mister. We have to use which CP in this step. Between 0 and 100 Celsius, for example, between of this number, the state of the matter is liquid. For example, between 0 and 100 Celsius, we have 25 Celsius, 30 Celsius, 45 Celsius. So 45 Celsius, it's which phase? Liquid phase, liquid state. So because it's liquid state, in this range we have to use the CP of the water, because water is liquid, and between of this range we have a liquid state. So 4186 times, and instead of delta T, bigger number minus small number, 100 Celsius minus 0. 100 Celsius minus 0. Good. So the answer, the third energy, which is equal to 1.8 times 10 power 4 joule. Now, in here again we have 100 Celsius, so we have to use the rule of 100 Celsius individually. The rule of 100 Celsius, we have MLV, you know. So the last, the fourth energy, MLV, yalla, same mass, 42 times 10 power negative 3 times, and instead of vaporization LV, we have 2.26 times 10 power 6. 2.26 times 10 power 6. So the fourth energy times both of them, and the answer 9.5 times 4. 9.5 times 4 joule. The last energy, finally, now we have done to find the energy between these two temperatures. Then we found fusion, and even though we have found the difference between both of them, and we have done that to find the difference, we have done to find the energy of MLV individually alone. The last, only one energy is left to find the energy between 100 Celsius and 111. Last one, energy number 5, MCP delta T equal same mass, 42 times 10 power 3 times, and CP between 100 Celsius and 111 Celsius. The state, it's steam, right? It's boiling point. It's above 100. I told you, above 100, the state it's become steam. It's become vaporization. So instead of CP, we have to write down the CP of the steam. We should write down CP of the steam, 2.01 times 10 power 3, and times delta T 111 minus 100. 111 minus 100. So find the last energy. You can use calculator. So the answer 9.3 times 10 power 2 joule. So now we have to find the total energy. Total energy, like the previous question, you can plus all of the energy. Energy number 1, energy number 2, energy number 3, 4, 5, plus all of them. And that's it. Okay. Question 2. Question 2 in here that we have, the question said we have liquid nitrogen. We have liquid nitrogen. For your information, nitrogen, it's gas state. Which state? Gas and vaporization. Which has boiling point, and even though here it's written which has boiling point. It's commonly used to cool substance to low temperature. How much energy must be removed from 1 kilogram nitrogen to completely? Okay, first of all, the question they told us, and they're talking about the question. They talked about the state of gas and vaporization. Because the state of gas vaporization, so you have to immediately think about MLV, because MLV, this is vaporization. You know. So immediately, so in here you have to write down the mass. The mass, what was the mass of the mass? In here we have 1 kilogram. So 1 kilogram times, and the LV of nitrogen, latent of the nitrogen, because nitrogen is gas. The nitrogen of the gas, LV, 2.01 times 10 power 5. So my time multiply both of them will be the same answer. So this is the energy. Question 3. Question 3. They said. Question 3. It said, how much energy is needed to melt? Be careful about this word. We have melt. Melting. You know it means what melting? Melting, it means convert solid to liquid. Melting, and convert the state of the matter from solid to liquid. Melt 225 kilogram lead. Note that the initial. So first of all, the mass of the lead, 0.225 kilogram. Note that the initial temperature, the initial temperature that we have of the temperature of the immediately after it has melted. Okay, look, in here, because the question said, the question said how much energy is needed to melt. Melt, it means converting solid to liquid. In this case, we have to find the energy of MLF, because MLF is fusion. And even though the question said melting is which of the diffusion now that we have studied? Melting, it means solid to liquid. So solid to liquid, fusion. That's why I told you this melting important. You can highlight it. In here, the question, they didn't give us the whole detail, but all of teacher, they will give you an exam, no worry. In here, the initial temperature we have 27.3. So the initial temperature TI, which is equal to 27.3 Celsius. The question said, look, the question said the initial temperature that immediately after it has melted. So this is the temperature TI. And if you know that the melting point, the question, I didn't give you melting point, but the teacher, as I told you, they'll give you an exam. So the melting point temperature become the final temperature. Okay. That one's become 300 327.3 Celsius. This become, yeah, the question they told you initial temperature. The other temperature will be final temperature. Even though we have latent heat fusion, which is equal to 2.45 times 10 power 4, and even though the CP of lead, yeah. Now find the total energy. First of all, how do we know that? We have to use which rule? Maybe you are getting confusing. Look, Baba, because the question said melting يعني converting solid to liquid. Because solid to liquid, immediately you have to think about fusion. Which rule that we have about fusion? Which rule that we have studied? It's related to fusion. This one, MLF. MLF, this is latent heat fusion, right? Because the question said solid to liquid, يعني latent heat fusion. So directly the first time use this rule. Q equal to MLF. Yalla, find the first energy. Mass. The mass in here we have 0.225 times LF latent heat fusion. In latent heat fusion 2 we have 2.45 times 10 power 4. Multiply both of them. The answer, the first energy will be 5512.5 joule. This is the first energy. Mr. Dunn, actually no. We know why not. We haven't finished yet, because I know in here, because the question said melting, and melting is solid to liquid, so we have to use this rule. But in here we have another thing. Look, if you notice that we have two temperature, initial temperature and the temperature of the boiling point. As I told you, this become final temperature. If you remember, I told you if we have two temperature, we have to do what? We have to find. We have to use this rule, CPM delta T. Because we have delta T and changing in temperature. How we have two temperature? Because you have two temperature, you have to find another energy. Since in here we have two temperature. Every time when you have two temperature, use this rule. The second temperature we have MCP delta T. You have the same mass, 0.225 times CP. CP of the lid 128 times, and delta T, as I told you every time, the bigger number minus small number. 327.3 minus 27.3, 300 is left. Right? Then you can multiply. The answer, the energy, the second energy will be 8,640 joule. So to find total energy, again plus both of them, total energy, Q1 plus Q2. Do it by yourself, plus both of the energy. So in here, this is important question, because we have melting, and melting, it means fusion, solid to liquid. Use this rule, MLF. Because you have different temperature, use CPM delta T. What if I'll change the question? Maybe the question said vaporization. In vaporization, it means MLV. You have to use MLV rule. Which question that in here now we solved it? It was question 3. Even question 3 done, finish. Question 4. Guys, question 4, same thing, but it takes time actually to solve this. But let me tell you one point in here that we have. Question 4, again same thing. Look, how much energy is needed to melt exactly? Again, you have melting. And because you have melting, do what? Use MLF. Again, use MLF. This is the number of the aluminum, each with a mass. This is the mass. Well, let me solve for it. It's okay. The important thing that I have to understand you, time is not that much important. How much energy needed? Melting. Yalla, melting. It means what? It means MLF. Exactly 100 aluminum. 1,000 aluminum, each with a mass. This mass is 14 gram. So the mass is 14 grams. As I told you, you have to make a kilogram times 10 power 3 kilogram. For recycling, assume that the initial temperature 26.4. يعني Ti equal 26.4 Celsius. What about the final temperature? What about the melting point? The melting point. This melting point every time, as I told you, will become, because you have initial temperature, and that's the melting points become final temperature. 660.4 Celsius. Good. Again, we have to do same step because the question said melting. Again, use MLF first energy. The mass in here we have 14 times 10 power negative 3 times a latent heat fusion. LF value will give you the latent heat fusion of aluminum 3.97 times 10 power 5. You can multiply, and the answer, I think it will be the answer will be 5.56 times 10 power 6. Let me do it. Is it right? Is it correct? 14 times 10 power negative 3 times 3.97 times 10 power 5. The answer. I forgot one thing. Look in here. In here, the questions they gave us the number of the aluminum. You have 1,000. In that case, because you have 1,000, you have to multiply this number of the aluminum with the mass, because the mass it was 14 times 10 power negative 3, right? With mass, you should multiply this, because in here we have the number of the aluminum. The number of the aluminum you have in here 1,000. So multiply this 1,000 with the number of the aluminum. 1,000. Okay. I forgot this number. Don't forget this number. How you get wrong answer. Multiply this. This is the number of the aluminum. يعني 1,000 multiplied by 14 times 10 power 3. Multiply with the mass. 3.97 times 10 power 5. So you get the same answer like this. This is the first energy, because we had fusion and we have to use this rule. The second in here, guys, look, same thing, We have difference in temperature. We have two temperature. As I told you, if you have two temperature, you have to use which rule? CPM delta T again. Yalla, the second energy, MCP delta T. The mass, again, use this, all of them. 14 times 10 power 3 times 1,000, because this is 1,000 is the number of the aluminum. You have to multiply in this question. Times. And instead of the CP, we have to use the CP of the aluminum, which is equal to 899 times. Instead of the delta T, bigger number minus small number, 660 minus 660 minus 26.4. Multiply and minus all of them, and this energy number 2 will be 7.98 times 10 power 6 joule. At the end, again, to find the total energy plus both of them, Q equal to Q1 plus Q2 plus both of them, you get total energy. Okay, guys, I have solved for you all this for 5 questions, so I think it will be this is enough. The other question you can't do it by yourself because it's so easy. Same thing. Section reviewing. We reach in section reviewing. Section reviewing. Let me solve question 1. Question 1, I think, important. And even though we studied this question 1 about losing energy and absorbing energy. Good. This question said, be with me. A jeweler working with heated 47 gold. If this topic, if you remember, it was between two objects. One of them, for example, gold, the other water, and so on. And here we have gold. The gold mass, 47 gram. This is gold. And must lower the ring's temperature to make itself to handle. If the ring is initially, and the first temperature of the ring, Ti of the rings 99 Celsius. And what mass of water? And the second object that we have in here, water. But the question said what? Find the mass of the water in here. You have to find the mass of the water. This is unknown. What mass of water at 25 Celsius? At 25 Celsius, this become initial temperature, of course. Ti 25 Celsius is needed to lower the ring's temperature to 38 Celsius. This become Tf 38 Celsius. So but I told you one thing. If you remember, the final temperature every time it will be the same for both of the objects, because in here it said temperature. This is last temperature 38. So this 38 is for water and even though for gold too. TF 38 every time. Final temperature for both of the objects. So in here we have mass of the gold and initial temperature, last temperature. We have initial temperature of the water, and even though we have the last temperature of the water, but I forgot to write down the CP of each one of them. CP of the gold, which equal to 129, and CP of the water, we know 4186. So find the mass of the water. Yeah, the same thing. Q1 equal to Q2. One of them absorbing, the other losing. Which one of them here absorbing? Again, we have transferring energy from the higher temperature to lower temperature. So again, the water, they are getting energy. So of course, the water, first of all, let me write down mCp delta T and mCp delta T. The left side, we can decide. Left side will be water, and the right side will be gold. So the water absorbing the gold, losing or releasing. So we have to find the mass of the water times, and the CP of the water we have 4186 times, and instead of delta T. If you remember, I told you if you have absorbing, it means TF minus TI. So TF minus TI equal the mass of the gold. We have 47 gram. Because this is gram, we have to convert to kilogram by multiplying 10 power negative 3. Or in that case, wait a minute, because in here you are free. Yeah, you are free. You can leave it by gram. But it's better to make it kilogram. I think it's better. Yes, every time in physics, make it convert it to kilogram. So the mass we have 47 gram. Make a kilogram. 47 times 10 power negative 3 times CP of the gold 129 times, and instead of delta T, because the gold, they are losing their energy, so you have to write down TI minus TF. So TI 99 and TF 38. 99 minus 38. Finish. Yalla. Write down the mass times 4186 times, and TF. Wait, instead of TF, we have to write down 38 minus 38 minus, and this is the water, and TI of the water is 25 equal, and the right side is 47 times 10 power negative 3 times 129 times 99 minus 38. Good. First of all, 38 minus 25, 38 minus 25, 13, and 13 times 4086 will be times 54418 equal, and the right side 99 minus 38, 99 minus 38, 61, 61 times 129 times 129 and times 47, 99 minus 38 will be 61. 61 multiplied by 129, and multiplied by 47 times 10 power negative 3. 47 times 10 power negative 3. So the answer 369.84. Finish. To find the mass, divide both sides by 54418. 54418. These two numbers are going to be cancelled. Divide these two numbers, the mass of the water, which is equal to, divided by 54418. The answers will be 0.00679 kilogram. This is the mass of the water. Okay. This question done too. Question 2. Question 2. This question said, why using concept of latent heat and internal energy, explain why it's difficult to build fire with a damp wood. Why it's difficult damp wood. Damp wood, it means why it's difficult to convert or to create a fire build if you have a wood and the wood tree, for example, it's wet and drenched, or there's some of the water on the tree, on this wood. Why it's difficult to make or to build a fire on the tree wood if there's a few water on it or wet? Why it's hard? Because if we have a tree and there's a few waters on it, it's difficult to make a fire because we have to give this wood a lot of energy to create a fire. It's difficult, of course difficult, because let me say in here we have this tree, and on this tree, on this wood, for example, we have a few waters. We have a few waters on it, and it's kind of difficult to create or to build fire on this wood that they have water on it, because on this wood we have some waters on it. This is water, so to make a fire on it difficult because we have to give them a lot of energy. They need a lot of energy to make a fire. To remove this water first, they make a fire. So in that case, we need a lot of energy. This is the result. A large amount of energy is used to increase the water temperature. Then become, because first of all we have to give this wood energy to this is water. We have to first of all convert this water to vaporization. Then after vaporization, building fire. So it takes a lot of energy actually. Question 3. Or leave question 3. Question 4. This question 4 important kinda, but I would like to tell you on here's because it takes time actually. Look, Baba. From the heating curve, we have this curve. Find the specific capacity or find the latent heat. It depends on the part of the question. So, for example, in here, from the heating curve for a 15-gram sample, as shown in this figure, estimate the following properties of the substance. First of all, part A, the question said, part A, the question said, find what? Find the specific heat capacity of what? Of the liquid region. You have to look at this. You have to look at this graph, and in which of the region that you have liquid. You have to first mention the region. In this region, of course. This is the region of the liquid, right? So how we can find specific capacity? What was the rule of specific capacity? Look, specific capacity rule. The question said find what? Specific capacity of the liquid. How we can find specific capacity? What was the rule of specific capacity? Cp, which is equal to Q over M delta T, right? This is the rule of specific capacity. So, in the up we have energy. I forgot to tell you, look, the horizontal line, this is we have energy, but the vertical we have temperature. So in here, this is the liquid region. In here, this point, you have to determine, you have to mention, you have to detect these 2 points. This will be the first energy, and this will be the second or last energy. So the first energy that we have, 8 point, this will be energy number 1, and that one will be energy number 2. In here that we have 8.37 and 15.8. We have 2 energy, and we are going to minus both of them. We are going to minus both of the energy. Yalla. And instead of Q, we are going to minus both of them. 15.8, 15.8 minus the first one, 8.37, 8.37. We wrote the energy in the up. What about the down? The mass. What was the mass? The mass, it was 15 gram, and I told instead of 15 gram, you have to convert to kilogram. Write down 15 times 10 power negative 3 times. What about instead of delta T? Delta T, we have to look at the vertical line, because vertical line is about temperature. So this is the region now that you have mentioned. You can extend this line to here, and in here to extend another line. Actually, I have to make it nice lines. So these two lines that I have mentioned for you, these two lines is the temperature, and the other two lines is energy. So this is the first temperature, 100, not 100 Celsius, because it's below 100 Celsius. So this become 80 Celsius. This is 80 Celsius, and that one 300 Celsius. So instead of a delta T, we have to minus both of them. 300 Celsius minus 80 Celsius. Yeah. 300 Celsius minus 80 Celsius. So done. You can minus and multiply. First of all, minus and the down multiply, then divide both of them. In this technique, we can, if their teacher is going to bring this, if they bring this in exam, you have to be careful and use this graph carefully to find the specific capacity. This is the horizontal line, which is about the heat. This is the horizontal line, which is about heat. And the vertical line is about the temperature. But in here, in here, I forgot to tell you, because in the horizontally we have heat by kilojoule. How we can make it kilojoule? How we can convert kilojoule to kilo? The rule of kilo, it was 10 power 3. So in here, when you found the value of energy, for example 15.8 minus 8.37, whatever the answer will be, any of the number, at the end we can make a bracket and multiply by 10 power 3, 10 power 3, because you have to make it to joule. Part B. Part B's question said, find the latent heat fusion. Find the latent heat fusion. Latent heat fusion, it means MLF, if you remember. Find the latent heat fusion. What was the rule of latent heat fusion? Latent heat fusion of what? Only find latent heat fusion. Good. This is a nice and good question. Look at me. Look at this smart. Look, latent heat fusion, the rule LF, which is equal to the rule of latent heat Q over M. Latent heat fusion. Maybe you are confusing, Mister. I have to choose or pick which of the region. Latent heat fusion we have studied. What was latent heat fusion? Latent heat fusion we studied is the energy per unit mass that the state it become converted from solid to liquid or liquid to solid, right? Solid to liquid or liquid to solid. So in that case, we have to choose this region, because in here we have solid and liquid, solid to liquid or liquid to solid. Good. Again, we have to find and mention both of the energy. This is the first energy, Q1, and this is the second energy, Q2. The second energy, 8, again same thing, 8.37 minus 1.27, and at the end, as I told you, because this kilojoule, we have to convert to joule, multiply the result by 10 power 3. What about in the down? The mass, the question, it is given, the mass, it was 15 times 10 power 3. And this is the answer of part B. Part B answer. Part C. Find the specific capacity of solid. Easy, yalla. First, you have to come back. You have to come back to this graph again. Mention and tell me, determine which of the region that in here we have only solid. And this is clear. This small region is solid. This small region, right? How to can find the specific capacity of the solid? What was the rule? Cp, which is equal to Q over M delta T. So in here again, we need the energy and we need the temperature. Yalla, on this graph, according to this graph, we have to mention again the energy and delta T, temperature. This one again. This one is the second energy, and this 0 will be the first energy. يعني 0, this is the first energy, and Q2 1.27. This become the second energy. 1.27 minus 0, and as I told you again, multiply by 10 power 3 over, and the mass, again the mass, same number, mass same value, 15 times 10 power negative 3 times, and instead of delta T, delta T, the temperature, it was on the vertical line, right? On the vertical line. Again, the temperature, this is the temperature, this is the second temperature, AT, and that one is 0, and here is 0. So this will be second temperature, and it will be the first temperature. So AT minus 0. AT minus 0. You can't calculate again. Yeah, and this is the second energy, this is the first energy, and this is in the up. You can extend this line to here. This will be the second temperature, and this 0 will be the first temperature, and so on. You can find the other same thing. Find the space about the vapor and vaporization. Same. I told you the idea. Okay, students, we have finished, and we finished the chapter 4 section 2, all of them. Now we reach chapter 4 section 3. This chapter is about relationship between heat and work, and what is heat and what is work and what is internal energy. Actually, we have studied what is internal energy, but now we are going to study what is the relationship between both of them. We study what is heat is energy, and even though we study internal energy, but now we have work. Good. First of all, work, to start explain what is work, we have this important definition. Work is defined as the product of force applied to an object and the distance moved by that object in the direction of the force. This is the important rule of work. We have work, which is equal to, this is the formula of work, equal to force times D. Again, in physics, I told you, we can only by the rule, we can get a lot of idea. We can get a lot of things, a lot of information. So in here we have what? Force multiplied by D, force times D. F force, and D, this distance, and W, this is work. So work is the relationship between force and distance, but how? Look, define is the product. Product, it means multiply. Products, يعني products multiply between both of them. Product of force applied to an object. يعني, for example, we have this table or this chair. You are going to apply force. You are going to apply force on this table. When you're gonna apply force on this table, the table, it start to move, right? Maybe take some of distance, and the table, it came here after when you applied a force. يعني it takes some distance. It takes some distance. يعني first we apply force on this table, and the table it keeps moving, takes some of distance. This is called D. Applying force F, and the table it start to move, it takes some of distance. This is D. This relationship is called work. يعني we have done some work to move this table. We have done some work. We applied force to move this table, and the table takes some of distance because it starts to keep moving. So this relationship is called work. Product force applied to an object, and the distance moved because the table starts to move. It takes some of distance. This is called work. And the unit of work. Later I'm going to tell you the unit of work. Leave this. Good. This is the first rule. This is the first rule of work. We have a lot of formula work, rule of work. This is the first one. The second one, W, which is equal to P delta V. P delta V. This is the second rule of work. P it means pressure. And delta V it means volume. But because you have this small triangle, يعني volume changing. Volume change. This is the second rule of work. Pressure times delta V. Then we have another rule of work. There is another rule of work. Rule number 3. Rule number 3 of the work, which is equal to W equal to PdA. يعني we have 3 general rule of work. F times D, pressure times delta V change in volume, and the last one PdA. P, it means again pressure, and D, this is the distance, and A, this is area. So we are going to use these 3 rules to solve an exercise. Now we understood and understand what is work. Work, it means applying force to any of the object. If this object they are taking some of the distance, so this is called work. Good. Look at this man, this person. What is he doing? This person, what is he doing? He's trying to take out this nail that is stuck inside this wall. He's trying to take out this nail that is stuck inside this this wall. What is he doing? He's applying force. He's applying some force. He's applying force. He's applying force to take out this nail from this wall. Sorry, but so what? Let you see what's going to be happening after that. Work increases. The nail internal energy is the nail surface. This energy transferred away from the nail surface as heat. Look, when this person he's trying to take out this nail from the wall surface, we know that this nail it's stuck inside the wall. When you are trying to take it out, frictions happen between the nail and the wall. When I would like to take out this pen inside of my hand, there is a friction. Look, there's a friction. This is called friction between the pen and my hand. This person he's trying to take out this pen inside this wall or inside my hand. There's a friction happening between my hand and this pen. So while frictions happen, then the temperature of the nail going to be increased. The temperature, because when you can't test in home. Check it. Even my hand I feel become warmer and getting more temperature because while I'm taking out so quickly, there's frictions between my hand and the pen. So work increases. Why? Because the nail internal energy increases. Work work can do what? Can increase the nail internal energy. We studied the previous section how we can increase internal energy of any object. If you remember, by deforming, by stretching, by compressing, by changing the structure, applying force. If you remember, if you remember, I told you the previous video. You can look at it. When I told you when I'm gonna break this pen, breaking like that or applying force, the structure of this pen going to be changed, and they are receiving a lot of energy, and the temperature going to be increased, and even though the internal energy same going to be increased. So this is the same thing when you are taking out this pen inside my hand. The particle of this nail, they are receiving a lot of energy, and that's why this nail temperature going to be increased. Because we have done work to take out the nail, and the nails, this is the nail, for example. Okay, this is the nail, and the internal energy or the temperature of this nail going to be increased, and even though the internal energy too become increased, and after a while leave the nail. For example, this pen temperature is so hot and they have a lot of temperature. Leave it like that. After a few minutes you can't touch it. You see that the temperature is getting increased, and it doesn't remain to be hot. The temperature totally changed and become cold. Why? Because I left this pen on this table, and after a while they had transferring energy from this pen to the air, because this pen, they have for example a lot of energy, and the energy of the pen, it become transferred to outside of the air to a lot of direction. So that's why the temperature of this pen become decreased with time. So leave this pen in here. You see that after a few minutes, or tea, when you are drinking a tea, after 10 minutes, leave it. You see that the temperature of the tea become decreased or become cold. Why? Because you left the tea, and without drinking, you left it in here inside or in front of you or on the table. The temperature of the tea are transferring surrounded in that direction. The temperature of the tea, they are transferring to the air, and they are losing their energy. That's why becomes cold. So in general, we have done some works, and the temperature of the nail going to be increased, internal energy going to be increased too. Why the temperature of the nail become increased? Now I said because we did work, or we have done work, and there's a friction between nail and the wall, so become increased kinetic energy. We said relationship between internal energy, kinetic energy, temperature, all of them directly proportional. So kinetic energy become increased, and even though the internal energy increased too. The internal energy, the kinetic energy, the temperature of this pen getting increased a lot too much. But after then leave it in here. After 1 hour or 2 hours, you can't touch it again. You see that the temperature is totally changed. The temperature of this pen become decreased or become cold. So because they have done transferring energy to the air, and they are losing their energy. That's why. Good. This definition. What is environment actually? Environment. It means. Environment means that everything is outside a system that can affect or affected by the system. For example, we studied in the in chapter 3, we studied buoyant force. There's two forces can affect this pen: gravity force and buoyant force. So if any of the force or anything can affect it, this object, this is called environment. And everything's outside system can affect this pen. This is called environment in general. So this is the rule that I explained it. When does the work done by the gas will be positive and when will be negative? You know what? When? If the gas expanded, you know what the meaning of gas expand? The gas expand. The size of the gas is going to be increased, and we have a large size, we have a greater, and we have a big or large size of the volume, extended or expanded. يعني the delta V become positive, of course. Why Mr. Positive? Because we have a large volume. Of course, delta V positive. When you have delta V positive, work done by the gas is positive too. How do you know that? And look, we have a relationship. We have a relationship. This is easy. Only by the rule you can know. I told you this rule. W equal to P delta V. If we have large volume, or if we have a large volume, we have a lot of volume, we have a big size of volume, the relationship between work and delta V directly proportional. If delta V will be positive, and if you have changing in volume, the change in volume delta V is positive, the work that we have done still is positive. But if the gas is compressed, I mean, this is the direction, this is compressed meaning, because I'm going to compress this pen in both of the directions, in left and right. I'm going to make this size of the pen smaller. It means that delta V become negative. When delta V become negative, the work become negative too. So when delta V is positive, work positive. Delta V negative, work negative. Because the relationship between both of them directly proportional. If the size of any object is going to be increased, going to be large, the work that you have done is positive. Vice versa. If delta V is going to be compressed, or you want to decrease the size, make it small, the work or the work that we have done is negative, and that's all. So one thing is left, and if the volume of the system or the volume of the object would remain constant, without changing, if it will be stable, it means there is no work is done. If work is stable, there is no changing of volume, and no work is done, and work is zero. Now we are going to solve example number 1. Be with me now. Question 1. Engine cylinder has a cross-sectional area. This is the area. So the area is 0.010. Area A, which is equal to 0.010 meters square. How much work can be done? And find what work by a gas in a cylinder if the gas exerted a constant pressure. This is the pressure value. Pressure value P equal to 7.5 times 10 power 5 Pascal on the piston, and with the piston in a distance. So this is the distance D. D equal to 0.040 meter. So I think it's so clear and so easy. How we can find work, guys, students. I told you, and we have explained 3 rules of work. One of them, it was W equal to FD, and the second rule, it was W equal to P delta V, and the last one, W equal to PdA. We have 3 rules. So now we are going to use which one of them? So who can tell me which one of them? The first one, we cannot use the first one, because in here we have force. In the question, they didn't give us any force. They didn't mention, or they didn't give us any. We don't have the value of force, so we cannot apply or use the first rule. The second one, we have W equal to P delta V. Actually, we have pressure, but we don't have delta V. Do we have in here change in volume? We have volume value? No. We cannot apply this one. What about the last one? This is the suitable rule. Why? Because in here we have pressure, look. And even though we have distance and we have area, so this is the correct rule to use it. This is easy, I think. So W equal to pressure, the value of pressure, 7.5 times 10 power 5 times the value of the D 0.040 times, and the value of the A 0.010. Multiply all of them. 7.5 times 10 power 5 times 0.040 times 0.010. The answer 300. W will be 300. The answer, look, 300. And even yes, I told you Work, the unit of work is joule, like energy. Sorry. Example. Question 1 example. Gas in a container. Gas in a container is at pressure of this number 1.6 times 10 power 5 Pascal. So this is the pressure. This is pressure value. This pressure P equal to 1.6 times 10 power 5 Pascal, and volume. The volume, this is volume number 1, because in here we have 2 volume. The first volume, V1 equal to 4 meter cube. What is the work done? We have 2 conditions. What is the work done? If it expands, it expands at constant pressure. This is important, be careful, to twice its initial volume. You know what's the meaning twice initial volume? Twice, first of all, twice it means 2. Initial volume يعني first volume. Twice initial volume يعني 2 initial volume, first volume. So this is of course equal to the second volume. So we are going to use this relationship. The question said twice يعني 2 initial volume يعني first volume. So of course V2 equal to 2V1, of course. If this is V1, that's totally become V2. So how we can find now work? In that case, you have to apply this rule, because in here we have pressure and you have both of the volume. Yalla, the value of the pressure we have 1.6 times 10 power 5 times delta V. We can write down V2 minus V1. 1.6 times 10 power 5 times, and instead of V2, we don't have V2. Let me write down V1 first. V1 number, it was 4 minus. We don't have V2, but we can use this relationship to find V2 in here. Look. That's why the question they give is this relationship to find V2. Write down this 2 times V1. Where's the value of V1? V1 equal to 4. So put the 4 in here. 2 times 4, 8. So now done, huh? We found the value of V2 volume equal to 8. So instead of V2, write down 8. So 8 minus 4, still it's 4. 4 times 1.6 times 10 power 5. The answer will be 6.4 times 10 power 5 joule. Part B, it is compressed at constant pressure. This is the same thing, but in here we have a different relationship. 1/4 initial volume. You know what is the meaning of one quarter? Quarter, it means 1/4 يعني 1/4. Initial volume, same thing. Initial initial volume يعني quarter 1/4 initial volume V1. Again, this will be V2. Yeah, same thing like the other question, but in here we have quarter. Yeah, again, find work, same thing. The same rule, same step. W equal to the pressure, we have same value, 1.6 times 10 power 5 times delta V, V2 minus V1, 1.6 times 10 power 5, and the value of V2. How we can find the value of V2 in here? I'll use this relationship, 1/4 times, where is the value of V1? The value of V1, it was 4. So to find V2, this 4 with 4 will be cancelled, only 1 is left. So the value of V2 will be 1. 1 minus, what about the value of V1? V1 value 4. You can use calculator, and the answer will be negative 4.8 times 10 power 5 joule. So this is the value of work done. And here we have 1/4 V1. So instead of V1, write down the number 4. Write down 1/4, cancel, 1 is left. So the value of V2 equal to 1. So students, study done, leave it, finish. Inshallah, for the next video, we are keep moving to solve the other questions are left. Thank you, and have a nice day.